Alrighty, so today we're going to talk about graphing rational inequalities. Okay? Yesterday, quiet please. Yesterday you solved rational inequalities algebraically. Today we're going to solve them graphically. Okay, now these tables, okay, don't really worry about the tables. Okay, we're going to graph them kind of on our own, and the tables aren't necessarily very important. So look at this first problem. Okay? When you look at this first problem, notice that you're comparing a rational function to a line y equals 3. Does everyone see that? Okay, and really what we're asked is, when is this rational function going to be below this linear function? Yeah? So we're going to use a graph to help us, kind of like we did using our test points, okay? So the first thing I'm going to do is I'm going to graph this rational function using what I know about radii, okay? So I'm going to draw myself a little sketch. So I'm going to graph my y, I'm going to call it y1. I'm going to graph y equals x over 4 minus x. Okay, so you can kind of write in this table, write over it, or just kind of write to the side. We're not really going to use the table today. All right, what are the roots of this equation?
No. Is this radii? Are we doing radii?
Finding the roots of this equation, yeah.
0.
0, 0. Set the numerator equal to 0. 0. All right, what are the vertical asymptotes of this equation?
X equals 4.
X equals 4. Are there going to be any tangent roots or together asymptotes? No. All right, what about my horizontal asymptotes, my end behavior? What's the degree on top?
1 over 3.
Degree on top is 1. What's the degree on bottom?
1.
1. So same degree. Degrees are the same. Play the coefficient game. What's the coefficient on top? 1. What's the coefficient on bottom? Negative 1. So this is y equals negative 1. And for my y-intercept, if I have a root at 0, 0, I must also have a y-intercept at 0, 0. I couldn't have another y-intercept because then I would not be a function. All right, so go ahead and use what we know, and let's plot a sketch of this graph. I plot my asymptotes and my root. It shows me that I'm going to have to draw in a curve in this top left section. Where's the other part of my curve going to have to be?
Bottom.
Bottom. Everyone okay with that? Okay, let's draw in now y2. y2 is the line y equals 3. Would you agree with that?
Mm-hmm.
So that's a horizontal line at y equals 3. Everyone okay with that? All right, so here's what we're being asked. We're being asked, where is the rational curve? It says less than 3, which means below the line y equals 3. Okay, so I want you to envision taking your hand and covering up anything that's above the line y equals 3. Okay? We are only concerned with the part that falls below y equals 3. So on our rational curve, I think I left that there. On our rational curve, that's going to be this piece, right? Would you agree that's below y equals 3? And that's going to be this piece. Would you agree with that? Okay, so what we want to do now is we want to write our solution, okay? And our solution is the x values that represent that part I just highlighted, okay? So the x values for the part that I just highlighted. So let's start over here. Would you agree that I would start at negative infinity? Okay. And I would go up to this intersection point. Would you agree with that? Okay. We're going to use our calculator to help us come up with that intersection point in a minute. So for right now, I'm just going to put a blank. Am I okay with that? Okay, but that's not all of my solution. I also have this piece of my solution, right? So I'm going to do a union. Where does that piece of the solution start? At 4, and it's a parentheses because it's a vertical asymptote, and it goes up to infinity. So let's figure out how to fill in this blank. I'm going to fill that in by finding this intersection point. So go to your calculator and go into y equals. And in y1, go ahead and put your rational function, x divided by 4 minus x. You have to be very careful anytime you enter in a rational function. You must put the entire numerator or the entire denominator in parentheses if there are more than one term. Okay? All right, what should I put in y2? 3. All right, I'm always going to zoom 6 to recenter my graph. And here's my piece. So the point I'm interested in finding is this intersection point right here, yeah? So I'm going to go ahead and find that intersection point. If I'll refresh your memory, it's second, calc, you choose 5, and you kind of want to move your arrow a little close to the intersection point you're interested in, and then you may press enter, enter, enter. So what that tells me is that my intersection point is at the point 3, 3. Now on your graph, that point might be close to where it actually is. It might be a little bit off, but that's okay. Because remember, when we draw these graphs, we're just drawing sketches, okay? All right. So that means that my solution goes from negative infinity to 3 union 4 to infinity. Okay. Let's talk for a moment why I chose to put a parentheses at 3 instead of a bracket. Why do you think I might have done that? Good. Look right here back at the beginning. Do you see how it said, when is my curve just less than 3? If that right there had said less than or equal to, then I would have made this a bracket. Does everyone see that? If it's just less than, you have a parentheses at your intersection point. If it's less than or equal to or greater than or equal to, you're going to have a bracket. Okay? So here's my solution. That's all the x values that make this inequality true. Okay? All right. Let's try number 2. All right, I'm going to start by coming up with my information to plot my rational curve 2 over x minus 1. All right, roots. None. Good. Vertical asymptotes. X equals 1. Any tangent roots or together asymptotes? No. How about my end behavior, my horizontal asymptotes? Yeah, let's talk about it. What's the degree on top?
0.
0. What's the degree on bottom? 1. Low over high. 0 equals y. All right, y-intercept. How do I get that? Good. So 2 over 0 minus 1 is negative 1. So negative 2. So I have a y-intercept at 0, 2.
Negative 2.
Sorry, negative 2. Thank you. All right, so let's plot. One more try. Oh, that was better. All right, where does the other piece of my curve have to go?
Top right.
Top right, good. All right. What's the other equation I need to graph?
Imaginary function.
Yeah, y equals x, which is our parent function. Goes through our origin, has a slope of 1. Okay. The next step is to interpret what you are being asked. Okay, so we're being asked, when is the curve what?
Less.
Good. So when is the curve less than to me means below
So why not?
the line? Yeah, so you're looking at the line on your graph and you want to know when is the curve below the line. So what I like to do is kind of visually cover up anything above the line y equals x. The only part of your graph that you're interested in is what comes below. So that would be this portion. And that would be this portion. Would you agree with that? Yeah? All right. So in order to write our solution, we're going to have to come up with these two intersection points, right? All right. So let's go ahead and find those two intersection points using our calculator. So I'm going to have 2 divided by, don't forget your parentheses for x minus 1. And in y2, I'm going to have x. Okay, will you please find your two intersection points? Second Calc 5. All right, what's our first intersection point? -1, -1. Okay, if you wanted to solve this by hand, would you still get that x value at -1? Yeah, you can definitely solve these by hand, but we're just kind of taking a little shortcut. What's this other intersection point? 2, 2. Okay, so we want to write the x values. Okay, we want to write the x values of the part we highlighted, right? So let's give that a shot. So my solution, my set of x values that are my solution, start at what? -1, parentheses or bracket? Parentheses, because it's just less than, right? If it were less than or equal to, we'd do a bracket. So -1 up to what? 1, because that's my asymptote. Parentheses or bracket? Parentheses. Will that one ever be a bracket? No, the vertical asymptote, it's always a parentheses. Union, where am I going to start again? 2. So it's now I'm looking at this piece. So I'm going to start at 2 with a parentheses for the same reason as it's -1. And we're going to go up to what? Infinity. Yeah. Questions on that? Yeah.
So on the solution part, I'm confused because for the first one, you did it like in spelled asymptote and it wasn't like -infinity. And on the second one, like why wouldn't you do it as it's getting closer to singularity? I mean, that does not count.
Let me see if I understand what you're saying. The solution that we're writing here are the x values that are represented in the part that we highlighted. And the part that we highlighted is anywhere that the curve is below the line. So it's not every x value of the graph, it's just the x values of the part we highlighted. Is that kind of what you're asking? Okay. You're okay? Okay, cool. All right, we're going to skip number 3. Go to number 4, please. So the table on your handout is just like if we were to look at the table in our calculator to get more exact points, but it's just not really necessary to me except for the intersection points. So we had meant to take those off, but we kind of forgot. Sorry. Okay. Let's go ahead and graph our rational curve. 2x over x minus 2 times x plus 3. All right. Any roots?
Yeah.
Yes, where?
0.
0, 0. Good. If I set 2x equal to 0, that means x has to be 0. Vertical asymptotes.
X equals 2x.
Good. Set each factor equal to 0. So x equals 2 and x equals negative 3. T for tangent or together. Do we have any tangent roots or together asymptotes? Nope. End behavior, which means our horizontal asymptotes. What's our degree on top? 1. What's our degree on bottom? 2. So low over high, 0 equals y. And where's our y-intercept have to be? 0, 0. Let's go ahead and graph. Okay, so once you get your information plotted, this is one of those times where we're kind of stuck, right? We don't really have any guide as to how to start. So normally what you do without a calculator is you pick a point and you plug it in. And that's what you'll end up still having to do most times. Today we do have our calculator. So let's go ahead and plot this and see what it gives us. Put your 2x, you got to put your numerator and your denominator into parentheses. So we have 2x over. You have to put the whole denominator in parentheses. So you're going to start with an open for the entire denominator, okay? Then you'll put a parentheses around each of your factors. So x minus 2, x plus 3, and then close your entire denominator. What am I going to put in y2? 1. So if we look at our graph, it gives us an idea of which way the curve goes, which we would have gotten the same information from plugging in points. So I'm going to be down in this section. I'm going to be up on here, down here. Okay. What's the other line we need to draw in? Y equals 1. Okay, I want to know where the curve is below the line. So either highlight, circle, do something. Find everywhere the curve is below the line. So would you agree that that would be this piece, and then this piece? Everyone okay with that? Okay, so for sake of time, because we're running a little short, I'm going to go ahead and tell you that this intersection point happens at the point -2, 1. And this intersection point happens at the point 3, 1. So can we write our solution? All right. First, I have to include this piece, right? This piece exists from -infinity up to what? -3. Then I'm going to jump to my intersection point, which starts at -2. It's a parentheses because there's only less than here. And we go -2 up to our asymptote of what? 2. And then union with 3 up to what? infinity. Everyone okay with that? Because that's where your intersection point is. Okay, check one thing out for me real quick. Look right here. I don't have to give you your calculator if I give you a table that gives you your intersection points. Do you see that? From right here, you would have been able to get your intersection points. So that's how this would exist on a non-calculator part. Or like problem number 6. Look at problem number 6. What is already given to you? The graph with the intersection points. So that's another way it will show up on a non-calculator part. Okay? All right. Okay, yep. I'm just about out of time. So on your homework, I do want to show you one quick thing.